In this video, we are going to be exploring infinite limits and limits and infinity. So in the past section, we learned how to find the limits of particular number. Now we are going to deal with limits and infinity or infinite limits. So recall, limit is a value where the function gets close to. So think about this situation. We plug it in negative really big number or positive really big number. What happens is if p is positive number and k is also a real number, this we have a number divided by really small, a really big number, then generally the fraction goes to 0. So limits as x approaches to negative infinity or positive infinity of this constant function over a power function, we will have 0. On the other hand, if you multiply k times x times p, and this x value gets very, very close to very big number because negative and then raised to the positive, you're gonna get either positive infinity really big or really small depending on what the k and p is. Okay, so keep that in mind. In fraction, if you pick really really big number on the bottom, it will be 0. If you multiply, you're gonna get either very big number or very small number. Limits and rational function and infinity is also another concept that we are going to talk about in section 2.2. It basically means we have a fraction, and when we calculate the limits, because we are looking at just general behavior at that particular point, we really don't have to pay attention to these extra terms. What matter most is the leading term. So when we take a limit at infinity, we are actually going to ignore all those extra term and just looking at the leading coefficient and then leading term and then plug it in positive infinity and negative infinity. So there are three cases where this will apply. M, which means degree, the exponent of numerator is less than the denominator, then limits at infinity or negative infinity is 0. Because think about this. If you have a higher power on the bottom because n is bigger, you're getting bigger number here. You're getting big, big, big. What happens when you have a big number? Generally, this fraction goes to 0. If they are same power, your limit will be just the leading coefficient. So you only have to look at the coefficient. And the last case is if you have a top heavy, so the function here has a higher degree, then it will be positive infinity or negative infinity depending on value of m, n, a sub n, and b sub n. So we will look at some cases where we use these three cases. Also, note another extra information. Limits as x approaches to infinity of f of x is same thing as finding the horizontal line of a graph. So if the problem asks find the horizontal asymptote, So if the problem asks to find the horizontal asymptote, you're gonna take the limits in infinity. So let's take a look at the first questions. Recall back chapter 2.1. When we talk about limit, we are not just going to plug it in negative 7. Technically speaking, we have to look at the one-sided limit each. And then if these two matches up, then limit at negative 7 exists, right? So let's start with the looking at one-sided limit and then look at negative 7. So part A, limit as x approaches from negative 7 from the negative side of f of x. Well, if the value is substituted into the function, we would have a 0 in the denominator, right? Because if you plug it in negative 7 here, negative 7 plus 7 is a 0. So since there is no way to remove the problem, we'll look at what happens around the value of negative 7 when approached from the left side. So that's what this means over here. This means, you see the negative part, 7 negative. This means we will look at what happens around the value of -7 when approached from the left. Now, on the other hand, this -7 plus mean we will look at what happens around value -7 when approached from the not left but from the right, because it's a plus from the right. Okay, so for me, the best way that I like to do is graph this function and see what happens around -7. So let's graph it over here using a graphing calculator. X divided by x plus 7 and graph. And right around here, you do see some parts that is not connected, and that's right about 7. You see that here. Goes -6 and then just there. So if you trace -7, you see that it's not working. So let's go from the negative side, which means over here. So as it gets close to negative, so actually I will screenshot this and pull it over here, graph of a function that we just did. Okay. Now for number 1, remember this was right around here is when -7 appears. And if you start tracing from the left side of the -7, this is -7 left side, what happens is the y value gets bigger. So limits at -7 from the negative side, left side, is getting close to really big numbers. So we use infinity. On the other hand, if you trace down and go towards the -7 from the right hand side, what happens is the value of y gets smaller. So limits at x goes to -7 from the positive side, it will be -infinity. So that's how you determine the function graphically. So I'll put this one on the side just as a reference. Then let's erase it, and then okay, so graphically I verified. So what does it mean? If one side goes to -infinity and the other side goes to a positive infinity, then limit at -7 does not exist, because left-hand side and right-hand side limits are different. Negative infinity and positive infinity is different. And recall from 2.1, in order for limit to exist, one-sided limit from the negative and positive has to match up. Okay, so the final answer for part C will be does not exist because the left side, left hand and right hand limits are different. Infinite limit. Okay, so that's how we get infinite limit right there. You might not always get a nice number out. So let's try number 2 as well. Number 2, we have a new function 4x plus 1 divided by x minus 5 whole thing square. And this time we're interested in -5 from the negative side, positive side, and exactly at 5. So we will look at one-sided limit at first to see if they matches up. If matches up, that will be the answer. It exists. If negative side and positive side, the one-sided limit does not match up, then we do not have a limit at 5. So Same thing, if the value is substituted into the function, we would have a 0 in the denominator, because if you plug it in 5 directly, that will make 0 in the denominator. Since there is no way to remove the problem, we'll look at what happens around the value of 5 when approached from the negative left side. So same thing over here. In fact, I will copy this one again and then paste this time this negative left side, and then we want to look at 5. Okay. And then this right over here, I'm looking at 5 plus, so right side around 5. Okay. Remember, limit is not exactly at the point, but limit is looking at what happens to the graph as it gets close to that value. So let's graphically approach the problem. That's the easiest way to see what happens. So I'm gonna delete the old one and then type in 4x plus 1 divided by x minus 5 whole thing square. Let's graph it. And then this is what happens. And if I trace it around this point, around the 3, it gets bigger, 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 and then we have some gap between 3 and 6, so 5, and then it gets kind of like going up too. So looks like from the left-hand side of 5, the function gets bigger, so infinity. Same thing here. As it gets close to 5 from the right-hand side, getting close to 5, it gets bigger, bigger, bigger. So both of them end up going to be positive infinity. So because each one-sided limit both approaches to positive infinity, we do have a limit this time, which is positive infinity. Because the left and right and limits both approach infinity. Okay. All right, now let's find the function value and the limit value. So a little bit of a recall. This notation means find the find the y value when x equal 20. So that means just directly plug it in, right? So whenever you see x, you're gonna replace it with 20. So all these x value will get replaced with 20. So be careful with the notation. This is just finding the function value. This is finding the limit value. So f equals 20. So 5 times 20 minus 3 divided by 3 times 20 plus 2. I'm going to get 5 times 20, that's 100 minus 3, that's 97. On the bottom, that's 60 plus 2, 62. So about 1.5645. We do the same thing here too. So f of 200, so plug it in for 200 this time for x. So 5 times 200 minus 3. 3 times 200 plus 2. So I'm having top number 997. Bottom I have 602. So in the decimal value I have 1.6561. Now we want to find the limit of infinity of f of x. So this over here is where the rule applies. This is a rational function because we have a fraction. And then for fraction, we only need to care about our leading term. So don't worry about all those extra, just the first leading term, and we plug it in. So my leading term over here is this, 5x over 3x. So this is the same thing as saying find the limit of 5x over 3x. The reason why we can ignore this, -3 and then +2, adding those small constant at infinity doesn't change much. That's why we look for the highest term and then see what happens. Well, if I'm looking at this one, this has a power 1, this has a power 1. In other words, m equals 1 and also n equals 1, right? The power that is on numerator is m, and then power on the denominator is n. So they both are 1, so it's a case 2. So limits at positive infinity or negative infinity, it will be just the coefficient, a sub m, b sub m. So this answer, limits at infinity, will be 5 over 3. So that's how you can use these cases to figure out the limits at infinity. Very easy when we are dealing with the rational function. Okay, so let's do one more practice. Same thing. We start with the finding each function value and then finding the limit using the 3 cases. Starting with a, I'm going to plug it in wherever you see x with 10. So this will be 10 minus 5, 3 times 10 squared plus 2 times 10 plus 2. So numerator, I have 10 minus 5, which is 5. Denominator, I have 300 plus 20 plus 2. So we have 5 over 322, which is equivalent to, in decimal, 0.0155. Same thing this time. I'm going to plug it in 100 instead of 10 wherever I see the x value. So 100 minus 5. 3 times 100 squared plus 2 times 100 plus 2. So I have 95, and then on the bottom, 30,222. In decimal, that is 0.0031. And lastly, finding limits and infinity. Since this is a fraction, I only care about a leading term. So this is the highest term on the numerator, and then this is the denominator. So that will be my leading term. So I don't have to look at all these extra one. I just have to look at the leading term of f of x, which is x over 3x squared. I'm gonna put 1 just to check and see which one is m value and n value. M end up being 1, that's the numerator exponents, and then n end up being 2. So this time I have m less than n. So let's look at the case where m is less than n. That's case 1. So what happens when I plug it in limits at infinity? It's equal to 0. So this will turn out to be just a 0. And it kind of makes sense. Think about this. If you're plugging in really big number, you get a number, but in this one, you have to square the number, multiply by 3. That's even bigger number here. So generally, when you have a bottom number bigger on the fraction, it's 0. So that makes sense. So that's how you use the theorems and the cases to find the limits and infinity. Okay, last bits over here. One more, number 6, and then number 7 and 8, we'll do the vertical and horizontal asymptote. Now for number 6, I'm going to let you guys try this one on your own because we did very similar thing 4 and 5. So number 6 is try on your own, but I'll give you the answer. A, you should have negative 12.3012. B, you should have negative 1245.5803. And then C, you should have negative infinity. Okay, so please work on this by referencing back to 4 and 5. Okay. Our last set of problems, 7 and 8, is to find the vertical and horizontal asymptote. Let's recall, vertical is when fraction, right? We have an undefined value. Vertical is where the function is undefined. So this is when the denominator equals 0, undefined value. Horizontal asymptote is to find the limit at infinity. Just explained it over here on the note. Okay, so number 7, I have a fraction. So to find the vertical asymptote, we are going to set the denominator equal 0, and that will be my vertical asymptote. So vertical asymptote will be x plus 5 equals 0. So x equal negative 5, and that will be my vertical asymptote. So function is not defined at negative 5. Horizontal asymptote will be finding limits of 8x over x plus 5. Again, I only care about the leading term. So I'm just looking at limit as x approaches to infinity of 8x over x. They both have same power, m equals 1, n equals 1. So by case 2, when m and n is the same, our coefficient is our limit. So our coefficient here is 8 and 1. So it will be 8 over 1, or simply 8. So it's a horizontal asymptote, that's a value. I should not actually circle it. So one more step is kind of like what I put x equals negative 5. Horizontal asymptote is a y value. So y equals 8 is the line of a horizontal asymptote. So make sure that you write it as a y equals 8 because it's a line. So I'm going to approach exact same method on number 8 as well. So starting with a vertical asymptote. So set this one bottom equals 0 and solve. So let's do this. 3x squared equals negative 2. Divided by 3, you have x squared equal negative 2/3. And you can't really find the denominator 0 because if you take a square root, I cannot take a square root. So that doesn't make sense. So this means there are no vertical asymptote. Horizontal asymptote is to find the limits at infinity of f of x, which is 3x squared minus 5 over 3x squared plus 2. We only care about the leading term. So this will be my leading term. So it's simply looking at limits at x equals infinity, 3x squared over 3x squared. Notice both m and n are the same. So it will be leading coefficient 3 over 3, which is equal to 1. So my horizontal asymptote, I do have a horizontal asymptote, which is y is equal to 1. Okay. So that is all the question that actually we have, let's do one more here. I erased it, but it's actually a good problem to work on. So number 9. Now, number 9, first realize all the past one I couldn't simplify, but number 9, it is factorable. So the function can be reduced as follows. So reduce the function, simplify as much as possible before you begin finding vertical or horizontal asymptote, okay? Because f of x of x squared plus 4x minus 5 over x squared plus 8x plus 15. Remember, this is a trinomial, so it factors as x plus 5, x minus 1. The bottom, it factors out as x plus 5, x plus 3. So these cancels out. So I have x minus 1 and then x plus 3. Okay, so this one over here, I have vertical asymptote. Because they cancels out, I'm only having x plus 3 equals 0. So you should not use x plus 5 equals 0 because they cancel out with top and bottom. So that's one thing that is different from previous one. Previous one, we did not have to simplify because it's already reduced. This one, you have to reduce and then only look at the remaining one. So over here, I have x equals negative 3 as my vertical asymptote. And horizontal asymptote is f of x limits at infinity of this function here. So x minus 1 over x plus 3. Look at the leading coefficient, which is x over x. M and n are the same, so the leading coefficient will be 1. So horizontal asymptote is y equals 1. All right, that's it for this section. On the next section, we will look at continuity 2.3.